Hi everyone, in this video we're continuing with key area 2.6 structure and function of the heart by looking at the heart's electrical activity. If you haven't done so, do recommend reviewing the anatomy of the heart as well as the events of the cardiac cycle. This will help immensely when looking through the heart's conducting system. So we're going to look at the frequency and the control of the cardiac cycle by the electrical activity originating from different structures within the heart itself. So your heartbeat, the electrical activity of your heart, originates from the heart itself because of these autorhythmic cells that make up the sinoatrial node, otherwise known as the SAN or the pacemaker. So the frequency with which it sends out these electrical impulses is going to determine the frequency with how often your heart contracts. So you find the sinoatrial node located in the wall of the right atrium, close to the vena cava. So as the SAN sends out these electrical impulses, it's going to coordinate the timing, the events of the cardiac cycle. So they will travel from the sinoatrial node, which is in the wall of the right atrium, and travel towards the AVN, the atrioventricular node, which sits in between both atria. So as these electrical impulses travel through the walls of the atria, that will trigger atrial systole. Atria walls contract and blood gets pushed down into the ventricles. Then from the AVN, the electrical impulses will continue on first down through the centre of the heart, then split up through the walls of the ventricles. And again, as the electrical impulses move through the ventricle walls, this will trigger the contraction, so it will trigger ventricular systole, and the blood will move from the ventricles into the arteries. So this electrical activity of the heart can be monitored using an electrocardiogram, and this gives us some really valuable health information about how well the heart is working. So a healthy, functional heart should make this pattern repeating over and over. And from this, we can calculate heart rate or easily spot when the heart isn't doing what we expect it to. So we have the P wave, and that represents atrial systole. We have the QRS complex, this big spike, which represents ventricular systole. And then the T wave, or recovery wave, which represents cardiac diastole. And we can also use these to work out the heart rate itself. So the length of time it takes to do one complete cardiac cycle tells us how often the heart can contract in 1 minute. So if this whole thing takes 1 second, it means our heart rate is 60 beats per minute. So although the electrical activity does originate in the heart itself, it can still be regulated by the nervous system and by the brain. So our medulla, which sits in the brain stem, it can send out signals via the nervous system to either increase or decrease heart rate by affecting the sinoatrial node. So if it wants to increase your heart rate, maybe during exercise, so think about fight or flight, sympathetic nerves will release the chemical noradrenaline, like an adrenaline rush, and this will tell the SA node to send out those electrical impulses with a higher frequency and thus increase your heart rate. And then when we want to slow the heart rate back down, the parasympathetic, nicknamed rest and digest, it will send out signals via parasympathetic nerves to the SA node, release the neurotransmitter acetylcholine, and that instructs the SA node to slow down the frequency with which it sends out its electrical impulses, and thus the heart rate decreases. So let's try some past paper questions. Pause the video and hit play when you're ready to reveal the answers. So question 1, the duration of the stages in the individual's cardiac cycle are shown in the table, and from the duration of those events, which would relate to the ECG, you have to calculate the heart rate of this individual. So we need to add up the duration of each of the individual stages for a total of 0.8, which tells us every 0.8 seconds we have a heartbeat. 60 divided by 0.8 for 75 beats per minute. The second question here refers to the autonomic nervous system control of heart rate. So, which branch of the nervous system will speed up or slow down, and which neurotransmitter, which chemical does it release to do so? So, sympathetic is fight or flight, parasympathetic is rest and digest, sympathetic uses noradrenaline, parasympathetic always uses acetylcholine. So to increase, it's got to be the sympathetic and noradrenaline, so option C. So let's try another one of the heart rates from an ECG, a little bit of a different style. So again, pause the video, you may want to zoom in if you can for this one. So from the ECG, we're told that each one of these boxes represents 0.2 seconds. So we use that to work out how long it takes for one heartbeat, one cardiac cycle to be completed. So we do that, we see it takes 1 second, therefore 60 beats every minute. So please, as always, let me know if you do have any further questions or anything that I can help you with.